how deep learning has changed over the last few years. So deep learning kind of exploded onto the stage, I would say, in from 2012 to 2015, especially in the enterprise world. And of course, people starting adopting neural networks and open source libraries and infrastructure, and trying to put everything together. And I call that deep learning 1.0. And deep learning 1.0 is fine, but if you've been in the field for a couple of years, maybe you've grown frustrated of how difficult it actually is to get your models at the quality level that you want and in production, right? And manage them in production. So over the last 2 years, we've seen some new technologies popping up. And well, those planets are now lining into what I'm calling deep learning 2.0. And the first planet is the transformer architecture. So you may be familiar with traditional deep learning architectures like convolutional neural networks or recurrent neural networks. And, don't get me wrong, these are still great. They still work for a lot of use cases. However, for the last 2-3 years, the transformer architecture has proven to be very, very efficient over a wide range of use cases, from natural language to computer vision to speech processing to time series. And we have customers who even apply transformers to life sciences domains, et cetera, et cetera. So transformers, again, are becoming the new standard way of doing machine learning. In deep learning 1.0, one of the main tasks you had to do was actually to build a huge data set to train your models on. Again, images, text, speech, etc. And it's a lot of time and a lot of effort. We see a shift to a technique called transfer learning, where instead of training large models from scratch every single time, we relied on off-the-shelf models that have been pre-trained by different companies, different teams out there, and shared, so that you can start from the pre-trained model and maybe use it as is. Maybe it's just good enough that you can use it directly, or maybe you're going to train it just a little bit on your own data, and in fact on a little bit of data. You don't need a lot. And so this technique is called transfer learning, and it's really changing the game. It's really speeding up the project lifecycle. So far, most of deep learning has been trained on GPUs, and GPUs are great. They're massively parallel chips, and they still work very nicely. But we see a new generation of hardware popping up, hardware accelerators for training and for prediction that have been specifically built for machine learning, which, with all due respect, is not the case for GPUs. ML hardware is something really, really interesting. Companies like Graphcore, Intel, Habana Labs are really building some very, very interesting chips that accelerate prediction and training quite significantly. And the last bit is always going to be tools. And of course, we've had tools before. We've had some really awesome open source libraries like TensorFlow and PyTorch and others. But it's fair to say, especially in the early days, they were difficult to use. And that's why I'm really putting the focus here on developer tools, because we really think that every application developer out there should be able to pick models, evaluate them, test them, and deploy them in their own applications, even if they don't have any machine learning background. So we really put the focus on building simple tools that hide the complexity, give you all the flexibility that you want if you really need to have it, but that also make it really simple to use and deploy those models.